So our question is this, that it is our plane, xy plane, and suppose this axis is x and this axis is y. And it is said that there is a magnetic field B vector and it is confined to a region which is small, for which R is smaller or equal to A. So that if it is said that this magnetic field is constant magnetic field, and this magnetic field is constant magnetic field, and it does not exceed the region where R is greater than A. So this is R from the origin. This is R. It does not exceed the region where R is greater than A. So this is a circle of radius A. And this is a and it is also said that there is a ring whose radius is B and B is larger than A. It is given that B is larger than A. And and B is larger than A, and this ring has mass M, and this ring has charge Q. This ring has charge Q. So we have to find that this ring, what is the angular velocity of this ring. First of all, we are amazed that why is there a angular velocity. We are amazed that why is there a angular velocity. So first we have to think that why is there a angular velocity. So we know that there will be an EMF induced in this ring, because it is said in the question that this B vector goes to zero in a small time interval delta t, and initially this ring is at rest, and when this B vector goes to zero in a time interval delta t, there will be a magnetic flux change through the surface attached to this ring. And if there is magnetic flux change in the surface, then there will be an induced EMF in this loop, and that loop is ring. So this induced EMF will create an current in this, and we know we know that induced EMF is E vector dot dl vector, and because this is a closed loop, so this integral is closed loop integral. And now here Kirchhoff rule fails because E vector dot dl vector for an closed loop is no longer zero. It is induced EMF, and that has a value other than zero. That has a value, magnitude of induced value, induced EMF larger than zero. So there will be an electric current. So there will be this, and there will be an electric current in this ring, because this is not zero, because it is not zero. So if there is an electric current in this ring, and this ring has a charge q, so there will be a force in this ring. And you should know that what is the direction of this E vector will be. What is the direction of this E vector will be? The direction of this E vector will be parallel to all D vector, and so the force will be in this direction, and there will be an angular velocity in this direction. So this will move this in this direction. So we have known that why there will be an angular velocity. Now we have to derive what will there be an angular velocity. So suppose that so we have to, first of all we have to find out what will be the induced EMF, and we know that magnitude of induced EMF is d phi dt, and d dt of integration of B vector, because this is not electric flux, this is magnetic flux, B vector dot dA vector. And here all B vector is this all B vector is going outward, is is coming outward, and all is parallel to the area vector. So this will cause 0 and it will be 1, and this dA is this magnetic field makes a same angle with all the small elements of area. So this will be d over dt of b 2 sorry pi A square. This will be the D. And dB dt, you know what is this? This is B upon delta T. And B square A square pi B square A square upon delta T. This will be an induced EMF. And we know this induced EMF is equal to closed loop integral of B vector dot dl vector. Sorry, very sorry. V vector dot dl vector is, this is we have written amperes, so this induced EMF is E vector dot dl vector, and that is pi B square A square upon delta t. And we can know what is this. Now we have this dl vector is this ring, this whole ring, because E vector will be produced in this ring, because this EMF will be produced in this ring. So what is all dl vector? Because all this angle will be zero and all at all the times. So this will be 2 pi b e equals pi b square a square upon delta t. And we lose our pi. So we get that E field, electric field in that ring will be B square A square upon 2B delta T. And then force on this in this ring will be EQ, and that will be B square A square Q upon 2B delta T. This force will produce this force will produce a torque. And what that torque will be? That torque will be FB, and so this will be B square A square Q upon 2 delta T. And this torque we know is because as force is a and change rate of linear momentum, so torque is change rate of angular momentum, L upon T. And we know what delta t is. We lose our delta t, and we know what our delta l is. Delta l is I omega, and we know what our I is moment of inertia, and for a ring that I is mb square. For a ring of radius b, mb square omega equals b square a square q upon 2. And then this omega will be b square a square q upon 2 m b square. So this will be the angular velocity of that ring. Think about that. There is no external force acting on it. We are not applying any force on it. Only there is a magnetic flux only there is a magnetic field area of radius a, and that is suddenly goes to zero in a time interval delta t. And there will be an induced EMF in this current, and because in this ring, and because induced EMF is produced in this ring, so there will be an electric field in this ring, and that will be this electric field. And because this ring is just charged by q coulomb, so this will feel a force, and that force will be upward because electric field is upwards. So there will be a torque, and there will be angular momentum, and so there will be an angular velocity. This is the beauty of physics.